office of the Always Believe House, and today we're going to learn about evaluating functions. We're going to learn about the function machine. When you input, it produces an output. Score it. It's going to be F-U-N, fun. So before I start doing anything, let me hit the record button. 3, 2, 1, 0. We are recording. Okay, so you should have this page on the magical whiteboard that appears in the Always Believe House looking at you. Before we get going, I'm going to go over some stuff. Okay, so write down y equals 2x plus 4. This is called equation notation. Okay, this is basically an mx plus b line, right? So the y-intercept would be 4, the slope would be 2, you would put a dot at 4, up 2, right 1, up 2, right 1, and you would draw your line, right? That would be that line. Also, the y-intercept would be 4, that would be 0, 4, and the numbers would grow by 2, 1, 6, 2, 8. That is equation notation. It helps you graph a line. If you wanted to, you could replace the y with f of x. It is equal to 2x plus 4, and this is called function notation. What function notation does is it lets me know what I'm plugging in for x. For instance, if I had f of 3 equals 2x plus 4, I would plug 3 in for x. And if we did that, let's just do that in our brain. If I replace the x with 3, I would have 2 times 3 is 6. 6 plus 4 equal 10. My output would be 10. So my ordered pair would be 3, 10, right? And input of 3 would output a 10. Today we're going to learn how to get the outputs of a function in function notation. So basically you're taking the y and replacing it with an f of x. For instance, okay, right here, let's write down f of x equals 2x. Okay, and this is going to equal to my y, okay? So, if I were to replace this x with 5, 2 times 5 would be 10, wouldn't it? If I were to replace this x with negative 3, 2 times negative 3 would be negative 6. I like putting the x with parentheses, and that way you can plug it in. They didn't leave any space in these notes to do that. So, basically, you're replacing your x with your input and calculating your output. That's basically what a function does. And remember, every x you input will not output 2 numbers. It's only going to output 1, which means the x cannot repeat. If the x repeats, the relation is not a function. Let's go to this one. X squared plus 1. We're going to do x squared functions after Christmas, and you are going to have a blast. So let's do this one. So we have f of x. And it's going to be, let's put x. And then we're going to have f of x equals x squared plus 1. Okay, so our function is x squared plus 1, and it's going to equal to our y. Okay, so basically you're going to take this x and replace it with parentheses. So I'm going to take that x and replace it with a 5. Now then, let's go through and do the math. 5 times 5 is 25. 25 plus 1 is 26. My input is 5. My output's 26. That ordered pair would be 5, 26, would it? So basically, they're telling you what to plug in for x. On the next one, what will I replace this x with? I'm going to replace it with negative 3. So I'm going to replace the x with the parentheses and put negative 3 in there. Negative 3 times negative 3 is a positive 9. 9 plus 1 is 10. This ordered pair would be negative 3, 10. So, a function notation is a way you can write it where you know what the x is and you got to calculate it to get your y. Most of the functions we'll graph will use x and y because of the x-axis and the y-axis. You use any letter you want, but on a coordinate grid, we'll usually use x and y. So let's keep going. Okay? So like I said, this is function notation, right? Okay? F is the name of the function. You could have g of x, h of x, j of x. Usually we use f because f stands for function. Okay? X is the input value. Okay, f of x is read as f of x. It is equal to function of x. Hold on, it's read. It is equal to y. I'm sorry. F of x is the same thing as y. So this would be function notation, and this would be equation notation. So this would be function notation, this would be equation notation. So if you replace the f of x with y, you will get equation notation. If you replace the y with f of x, you get function notation. And the purpose of function notation is that you can put something in the parentheses to know what your input is. Okay, write each of the rules from the function machine above using the function notation. So right here, I guess we're using these rules. Multiply by 3. And then add 9, right? That's basically what that function's telling you to do. You're going to take the x, multiply it by 3, and add 9. This would graph a line. The starting number or y-intercept would be 9, and the numbers would grow by 3, wouldn't they? Oh. Now then, let's go here. To evaluate f of x equals 3x for 9, substitute 5 for the variable x and rewrite it like this. Notice they replaced the x with parentheses there, didn't they? Therefore, f of 9, or f of 5, 3 times 5 is 15. 15 plus 9 is 24. And this would be written as an ordered pair of 5, 24. That's what you would actually graph, okay? So, remember again, the function notation, that f of x is the same thing as y, but it lets you know what you're plugging in for the function. And then you'll do the math and you'll calculate your output. That would in turn turn into an ordered pair on the graph of that function. Ho, 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 ho. So let's keep rocking and rolling. Okay, I'm going to zoom in so you can see this better. Okay, so this one right here, we want to find the function of 4, right? We want to find the value of 4. So I'm going to write down 6 parentheses. I'm going to put 4 right here plus 9. Notice I'm replacing this x with parentheses, right? So I need 2 sets of parentheses in there, right? So I'm going to replace the f with 4. Now then in this problem, we will not do 6 times 4 first, will we? We're going to do the parentheses first. So 4 plus 9 is 13, and 13 times 6 is 78. So our output would be 78. On the next one, write down 6 parentheses, replace the x with parentheses. Do y'all see how I replace the x with parentheses? Now then, what will I put in that parentheses? I'll put -6 because the equation's in function notation, and -6 is our input. Now then, -6 plus 9, -6 plus 9, we're doing this first, 6th grade math, -6 plus 9 is 3, and 3 times 6 is 18. Okay, if you're weak with your integers, it's like, man, I wish I could go back to 6. This is 6th grade integer work here. So you're just doing the integer work you did in 6th grade. Let's go to number 2. Okay, on number 2, when we replace the x with parentheses, it will look like this, won't it? And then we're going to take the number that we're plugging in. Notice this is g, so this is a function named letter g. So on the first one, I'm going to rewrite this with the parentheses, and then I'm going to take that 1 and input. So I'm going to do 1 squared, 1 times 1 is 1, and 1 minus 11 is -11. If you have trouble, type this in as is into the calculator. If you are not using the parentheses, it may do it wrong, especially when you plug in a negative. So make sure you're typing this as is into the calculator to get your answer. If you're weak with your integers, you're going to have to use a calculator. And you've got to use that parentheses, because if you put a negative in there, it could be wrong when you do an exponent. Let's go to the next one. Replace the x with parentheses, and then I'm going to take the -3 and plug it in there, right? So I'm going to do -3 squared. -3 times -3 is not a -9. -3 times -3 is +9. 9 minus 12 is -3. Like I said, if you have trouble with that, you're going to have to use the calculator. And make sure you're using the parentheses the way I'm teaching you. If you're not, it's going to be wrong. Always replace your variable with the parentheses and plug in your input. Let's keep rocking and rolling. Oh. This is F-U-N, fun, fun, fun. Notice on number 3, there's 2 x's, right? So when I plug this in, I'm going to have 8 minus parentheses over parentheses. I'm going to plug in my input into 2 parentheses, aren't I? This function has more power. A function can have more than one variable, especially quadratics, and we'll get into that after Christmas. So let's do this one. Draw a fraction bar, 8 minus parentheses over parentheses. And what will I plug into that parentheses? I'm going to put a negative 8 in here, right? So I took the input of negative 8 and I put it in both parentheses. Now I'm going to do the math. Get the numerator and then divide by negative 8. 8 minus a negative 8. The 2 negatives turn into a plus. So this will turn into 16 over negative 8, which is a negative 2. If you can't do that, you've got to use the calculator. Hit Control Divide and type it in. Okay, let's do the next one. Draw a fraction bar. 8 minus parentheses over parentheses. Replace all of the x's with parentheses. Now then, let's plug in our input. Our input is 8 in it. 8 minus 8 is not 16, is it? 8 minus 8 is 0, and 0 divided by 8 would be 0, would it? Okay, so basically you're taking the number that's in the parentheses, plugging it in for x, doing the arithmetic, and writing the answer. Obviously, I could do the arithmetic in my brain. If you're weak with the integers, you've got to use the calculator. And make sure you're using the parentheses. Just don't write the number in. Let's continue on. So much fun. Okay, for P of x, on this one right here. So let's write this again. Write down P of x equals 8 minus x over x. Is there a value where it cannot be evaluated? So is there a number we can plug in here where the answer would be no solution? Okay, so think about this. Because you're going to have to, you won't do it in Algebra 1, you'll do it in Geometry and Algebra 2. You're going to have to write down where that function does not work. If you plug in 0, so 8 minus 0 over 0, can I divide by 0? I can't do it, can I? So an input of 0 would be no solution. Okay, you can't get it. So this function would not exist at 0. The value won't work, okay? And you'll get into that in Algebra 2. Okay, in Algebra 1, this you won't have to worry about this. Now then, let's keep going. Okay, this is the way I teach my kids on this. So we have g of x equals this, and this is my input. And notice, how many inputs do I have? I have 4 of them, right? That means I'm going to get 4 ranges, right? Okay, so this is the way I would teach you to do it. You're going to write down 4 parentheses minus 12, and let's do that 4 times. Now then, I'm going to take this 1 and plug it in. Plug in the 3, plug in the 5, plug in the 7. Does everyone just see what I did? I took down the x, I replaced it with parentheses. I have 4 domains, so I'm going to plug each domain in, and you need a new equation every time you plug a domain in. If I had 6 domains, I would need 6 equations. Now then, I'm going to get 4 answers, aren't I? Okay, so put an equal. The first answer, 4 times 1 is 4, minus 12 is negative 8. If you cannot do this arithmetic in your brain, you have got to use a calculator. You've got to use the calculator and use the parentheses, just like I'm teaching you. 4 times 3 minus 12. 4 times 3 is 12. 12 minus 12 is 0. 4 times 5 is 20. 20 minus 12 is 8. 4 times 7 is 28. 28 minus 12 is 16. So my range, I'm going to use R for range, start a brace, go from the smallest to the largest without repeating values, right? This would be my range, wouldn't it? Okay, so if I have 4 domains, I'm going to end up with 4 ranges, unless one of them repeats like they will after Christmas. Oh, they will repeat after Christmas. How does that work? You have to wait to find out. Ho, 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 ho. Okay, now then, let's keep rocking and rolling. Now then, we're looking at a graph, right? This is not going to be hard. So we want the function of -4. So remember, the -4 is our x in it. So go over here to the graph. 1, 2, 3, 4. My -4 is right here in it. Now then, go up to the graph, and I'm right here, aren't I? And that is a bad one because you can't really accurately get it, okay? 1, 2, oh, I'm sorry, that's wrong. That's -3. So -4 is right here. Jiminy Crickets, I can't count. So if I go up, my -4 is right here, right? That ordered pair is -4, -2. So if I input -4, my output would be -2. So I don't know what the equation is. So all I'm doing is going to the graph and getting the y from the ordered pair. Now I want f of 0. This would be our starting number, right? Or the y-intercept. So if I'm at 0, it's right here in it. So if I plug 0 into the graph, I will get 0, won't I? This ordered pair would be 0, 0, wouldn't it? So an input of 0 would output a 0, wouldn't it? Because it goes to the origin. Let's do, okay, let's do this one, f of 3. Jiminy Crickets. So f of 3. So I'm going to go over 1, 2, 3 right here. Did I count right? F of 3. 1, 2, 3. If I go down, this is a bad one. Let's do f of 2 because f of 3 doesn't work. Let's do f, scratch this out, put f of 2. So if I were to go over 2 and go down, I'm right here, aren't I? And what would that ordered pair be? It would be 2, -2, wouldn't it? So if I input that 2, my output would be -2, wouldn't I? So this would equal to -2. If we did the 3, it would be right here. It would be -1 point something. We don't know what that is. That's why I switched that number. And lastly, let's do -5. So the -5 point is right here in it. And it would be -5, 0, right? So if you input -5, your output would be 0. Okay, so on a graph, if they give you the input, you just go to the input and go up or down to where that graph is and get that ordered pair. The y of the ordered pair will be your output. Remember, your x is your input, your y is your output. Ho, 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 ho. Okay, now then, we're going to go to the bottom where we have a table, don't we? So now then, on that table, this is going to be my x, and this is going to be my f of x, right? Or it would be x, y, right? This is basically your ordered pair. So if they give us x, if we want to get the f of x, we're going to go to the right. If they give us the f of x, we're going to go to the left. For instance, if x equals 1, my f of x is 5, right? Piece of cake, huh? So you're just reading the table. If the domain is 1, that's right here, my range is 5, isn't it? If f of x is equal to 11, so my 11 in f of x is here, what is the value for x? I'm going to go backwards, it would be 4. You're just reading the table, aren't you? If the range is 11, so if my range is 11, my domain is 4 also, right? We're repeating these, aren't we? What is the value for f of 3? This is my x in it. So where's x equal 3? It's right here. The value for f of 3 would be 9, wouldn't it? So you got to figure out if they're giving you the f of, or the x or the y. If f of x equals -1, so -1 right here in the f of x column, the x would be -2. Oh, that's more power. And if f of x, is f of x a function? Would it be a function? Would it be a function? Pause it. And unpause. Would it be a function? Yes, it would. How do you know? The x does not repeat. Ho, 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 ho. So your x is not repeating on that. Okay? That's how you know it's not a function. You're going to do your homework next. Okay? I hope you have a great, great day. Remember, you were made to do wonderful things. You are awesome. And always believe.